Hi, welcome back. This second video in the week one series is going to focus on some terminology that we're going to use in our programming in the course. So the course's main activity is going to be computer programming. What is computer programming? Or another name for computer programming is software development. One definition that I like very much is that programming is specifying step-by-step instructions for computing some answer or solving a problem or completing a task. Okay. Now this is similar to a recipe that you would use to cook something, or let's say bake a cake. Okay. There's a certain sequence in which you have to do things. You can't put the icing on the cake until it's actually been baked. You have to mix up the batter, and then once you've mixed up all the ingredients in the batter, you put it in the oven for a certain amount of time. Only then, after you take it out of the oven, can you ice the cake. If you put the icing in the batter before you bake it, then it's going to be all messed up. It's not going to be a correct solution to the baking a cake problem. So similar to that in our computer programs, we have to get used to the idea that there is a specific sequence of things and ordering to which we are going to do things. And so you'll see that. A program is simply the set of these step-by-step directions that are saved in a computer-readable form, so we don't have to retype the commands every time. And so you can type the program once and then run it many times and get the same results. Okay, one complication that we have is that we can't use English languages, human languages I should say. English is one of the human languages, but any of the normal human languages like English or Chinese or Russian, anything, they're not precise enough to avoid ambiguities or misunderstandings in meaning. One example would be if I would write a sentence and use the wrong punctuation, I use an exclamation point where a comma should be, or even if I misspell some words. Humans are capable of looking at that and figuring out what the author meant by writing that, even though there were mistakes. Computers, by the contrast, cannot get over those kind of details. So we can't use human languages for writing programs. We have to use special purpose computer languages. And so we're going to use the Java programming language, which is one of the most widely used languages today for our work in CSC120. Okay, and Java is based on what's called the object-oriented programming model. So to represent data in the computer's memory, okay, we have to have some way of organizing it. So the keystrokes that you would enter into a word processing document, or the numbers that you type into a spreadsheet cell, perhaps the images that are used in a photo editor, the pixel values, all of that has to be stored somehow in memory, and then it has to be organized in a way that we can access it. So the most widely used languages today use an organizational principle which is called object-oriented data representation. And so let's talk about what an object is. Okay, so anything from the problem domain, the area of the world that we are trying to solve, that we're going to represent in a program, is stored as an object. Okay, and so we can some example objects, anything that you'd see in the world that you want to work with, TV sets, mammals. A student is a good example of an object. Each of you would be an example of a student object. And objects have these things. Every object has a unique name, so we can tell which object we're talking about. If we have more than one object in our program, we need to be able to specify which one we are specifying at any one time. Objects also have one or more properties or data values. Think of you as a student. You would have many different data values that describe parts or aspects of you: your name, your address, your phone number, your major, your number of credit hours that you've earned, multiple things. Each of those individual data values would be a property of the object. And then objects have one or more methods. These are capabilities or things that we can ask the object to do. Okay, so that's important. Those are important terms when we talk about objects. Okay, now let's think about a TV set. You're probably familiar with TV sets from your life, and you know that in any one house or apartment or location there can be multiple TV sets. So how do you know which one you're talking about? Hey, turn that TV off. Okay, well, which one should I turn off? The living room TV, the kitchen TV, the garage TV, wherever you have your TVs. So each one of those has to be uniquely identified. Okay. So the name has to be different from any other TV set or object that you have in your program. Okay, and now what are the properties and the capabilities of any particular object? They come from a standard general definition, which is called the class definition that the object is based on. Okay, so class is the type of object we're talking about. So a general description of a student would include name and address and number of credit hours and major as properties, and then also capabilities. So the class is a general description of an object that can be created from that class, and the description includes the properties and methods. Okay, so let's think about a TV set specifically as an example. Okay, the TV set has properties. Now the properties of the TV set would be values that describe the current state of operation. So if you're watching TV at a particular time, what are some properties that would describe the current state of the TV? And then how about methods? Methods are operations or things that you can ask the TV set to do. So most modern TV sets are controlled by a remote control device. And so what can you use the remote control to do with a TV set? What can you ask the TV set to do where there are button presses on your remote that you can work with? Okay. Well, you could come up with a long list of for each of these. These are some properties that I thought of when I was putting together this presentation. Okay, so describing the current state of the TV set. What channel are you currently watching? What channel is it tuned to? So the channel number would be one TV set property. Another property would be the volume setting. Is it high, low? You know, there's usually it's a numeric value on modern TVs, right? Also things like the brightness and the contrast, the picture balance, and all kinds of other properties that you could have here. And another thing that you might not have thought of is whether the TV is on or off. Okay, so sometimes the TV is on, sometimes it's off, right? So that's another property that we could keep track of. A lot of times in our programs, we aren't going to have every possible property for an object, only the ones that make sense for the problem that we are trying to solve or represent at that time. And then what are some methods or things that you could ask the TV set to do with the remote? Well, usually there's a way to go up one channel or down one channel. So channel up or channel down would be different methods or capabilities that the TV set would have. The ability to raise the volume or lower the volume, volume up, volume down. Also, usually you don't have to cycle through all the channels. If you're watching channel 3 and you want to watch channel 19, you don't have to continually press channel up. I mean, you could do it that way, but also usually there's a way to go directly from channel 3 to channel 19 without cycling through all the channels in between. So some kind of set channel capability or method would be usually provided, and then how to turn the TV on or off, a power on, power off kind of method. Those are just some examples of methods for a TV set object. Okay, so our programs are going to be collections of class definitions for all the different kinds of objects that we're going to have. And then in our main part of our program, we will define the objects that come from these classes. And then after we've created those objects, we will ask the objects to carry out operations in a specific order. So the example in my demo that I'm going to come up with is going to be taking a look at a program where I'm going to write a program that displays several balloon objects on the screen that can be in various colors, various sizes. We'll talk about that in the third video in this series. See you then.